Good evening. We will be diving into the topic, developing software for 100% availability. Let's look at the outline. Why the financial technology industry need 100% availability? What are the critical steps involved in the development of mission critical system? And then the Agile. Agile and Lean has changed almost everything that we know of. And then how the mission critical software development has been impacted because of Agile. Let's move on. Anyone in the audience can answer this question. What is availability? In the simplest terms, what is the availability? Any guesses? The simplest term that goes in line with availability is uptime. To illustrate further, let's look at a table. The first column talks about availability as a percentage, starting from 90% to 99.79. And I also represent it using a nines scheme, where it starts with 1 9, ending up with 9 nines. You at the back might not be seeing it, starting with 90% going up to 99.69. And then the respective downtime. If you run a system for 365 days in a row, what is the respective downtime is also specified here. Right. Let's start with a simple example. Can you guess what is the number of days that the typical Sri Lankan railway system is out of order? Take a guess. Is it 20 days? 10 days? Come on. Nirmal, what's your guess?
15 days, more than 15.
More than 15. It's about 5 days, not that bad. So if it is 5 days, the downtime should sit between these two, isn't it? In fact, if you actually calculate it, it's around 98%. That's not bad for a South Asian country. Right. Let's look at something relevant for us. What about the great Amazon Web Services? AWS Cloud. What is their uptime? What is their downtime? Sorry? It's between?
They are providing 5 9 and 5 9.
5 9. You mean here? Okay. That could be what we see in their marketing materials, but their track record shows they are somewhere here. It's some years they are doing really good. There was a year there was like less than 10 minutes outage, but typically it's between 1 hour, 2 hours. Right. Let's go to the bottom. Where could this be? Any ideas, guys? Think about the most reliable system that you have seen in your entire life. It is none other than the Boeing 747 main control system. It is so reliable. On a 4-hour trip, the chances of it going down, if you average it out for a year, is just 31 milliseconds. That is how reliable that is. Can you guess how reliable, how available Millennium trading systems in tier 1 markets? Any guesses? Is it between 3 nines and 4 nines, just like the Amazon? Or is it between 4 nines and 5 nines? Any guesses? Come on, guys. You guys are not engaging. Please? 6 nines and 7 nines. 6 nines and 7 nines. Okay, good guess. What about from this side? Let's give it a try in another slide. Okay, why the fast-moving, fast-growing financial technology industry need high availability? We have to answer that question. After a tired day, tired but productive day, Knight's Capital employee is waiting for a moment. He must be tired, but he must be happy about his day, right? His sit. This is on the same date that Knight's Capital lost nearly $440 million in just 30 minutes because of a software bug. They bought at a higher price and then sold at a lower price because of a software bug. And in 6 hours, their stock, Knight's Capital stock, fall from $12 to $2. And during 6 months, they were acquired by their rivals for a penny. It's at a big discount. It's a big, costly mistake by a software bug. NASDAQ. NASDAQ is one of our competitors. It's sometimes thrilling to see your competitors struggle. I know it's bad. I know it's bad. It's not ethical, but you can't help the feeling, right? The true story is the financial technology industry, the entities are so mingled with each other, so connected, interconnected with each other. Downtime of a single system may cause millions and millions of dollars of loss of revenue. Not only that, it will also cause your customers to move away from you. Because every customer is connected to all the venues, it's very easy for them to switch. Just make a decision, switch a button, that's all. So because of that, we as trading systems, we have to make sure that our systems are not going through big outages. In our world, there are people called regulators. They are the policemen in financial technology industry. They will not only fine for outages, they will sometimes cancel the trading license. Sometimes the big executives may even have to go home in case of a big outage. So it's serious. This is that number. This is the availability record of all tier 1 markets that MilleniumIT trading systems run. And look at this last decimal. If you know how bad the software developers feel about having a 4 as that last decimal, how bad the software testers feel about having 4 at that as that last decimal, you wouldn't imagine. They miss 6 nines because of a single incident. One single incident. One software bug. A fairly complicated one. But one single bug has caused it to degrade from 6 nines to this. That's the pressure that they have to go through, and that's the cost of a bug. Right. Next, we'll move on to understand what are the critical steps in the development cycle that makes mission critical software high available. When you go in front of the prison in Valikade, you see a statement. What is that? Sirakaruvoda manushayoya. Even prisoners are human. After we lost, our cricket team lost for Afghanistan, now they have changed it. Now they are saying it as, even cricketers are human. The point I want to highlight, if cricketers are human, software engineers are definitely human. So it is It is impossible for software engineers to build infallible systems. That is why this statement is very important. If you can't build infallible systems, you have to make it recover before your customers notice. It's easier to tell that, right? But when your system is expected to process data and then release data at a rate, when you have a real-time system, they will notice after a few milliseconds. So your systems are expected to recover within milliseconds. That is why it is important and why it is hard. Let's look at architecture and design, but I will not be going through thoroughly there because Suho has already covered most of the concepts. Let's start with a simple but powerful concept, that is being aware of the environment. We know for a fact that machines can fail. In fact, machines fail. Disks can fail. Network can fail. Databases fail. That's why we have bonded network cards. That's why we have disk arrays. That's why we have database clusters, isn't it? But what about the software? For the software to achieve the same level of resiliency, there should be a cost. That cost is having a fault tolerance built into your system without interrupting your business. Because developing business is something that should happen fast, in an elegant fashion. So the trick here is having automatic failure recovery as well as multiple failure mitigation options built into the framework that your business is built upon. Before the likes of Zookeeper came into existence, around a decade ago, MilleniumIT, we developed something called a System Guardian. It's a fault tolerance framework where all our applications are built upon. So it provides the capability for component developers to develop software on top of a already failure resilience framework. It is easier for people to develop functionality because of that. Let's dive in to understand how automatic failure recovery happens. First, the detection is important. Then the fault mitigation, and then the recovery. So how do you detect? Is through interruptions and heartbeats. When the other component does not heartbeat, or there's an interruption received, okay, the child process is killed, then you know there's a detection. And then the fault mitigation. Usually we handle fault mitigation through redundancies. I think Suho covered that very well. Then comes the recovery. You have to reconnect and restart processing, honoring the ACID properties. Can you guess who said this statement? Anything can go wrong. Anything that can go wrong will go wrong. Please, make a guess. Yep. Well, that's Murphy's law. How about this one? Do you agree with this statement? Please raise your hand if you agree with this statement. I don't consider you as a software developer if you don't agree. The reason is, if you actually develop a practical system, that means you know for a fact it happens always. It happens always. It's by Finnegan. Haven't heard of him, right? So we have to be prepared for anything, for virtually anything. That's why having multiple levels of fault mitigation will really help you. We want our systems to work hard. Because of that, the system is expected to have multiple levels of fault mitigation aspects built into it. For example, component replicas. Moving into, if a component fails, moving into the other replica component, supposed to happen automatically. Machines, even partitions, and sometimes backup sites, or in regions in the cloud terms. This is an extension of what Suho talked about. So we expect these things to be built into the system. In fact, most of the fault-tolerant fabrics that you find today have these features. In addition to that, some things can't be fully handled by the system itself because it requires manual intervention. So there should be a way that we could start components, we could start systems with the previous state. So that is called warm starting. And then in worst cases, you might even have to throw away data. That's like the worst case. That's a phase of a mission critical systems developer. You can't show your face to your customer after that last thing happens, because you haven't recovered data after all the attempts, and then you're just bringing up the system to make sure that you can do whatever the system is supposed to do after that. So even that option is an option, and that should be built into the system so that we are prepared for anything, any case. Development is important. It is coding and testing. So defensive programming, how many of you have heard about defensive programming? All right. What is that you are being defensive to? You can defensive to your customer. Is it defensive programming? Sometimes it is. But in this case, I'm talking about defensive to inputs. When you're programming, defensive to user inputs. Defensive to how external systems are interfacing with you. If there is garbage in the input, if there is out of range values in the input, should you crash? Should your program behave abnormally? I don't think so. We should reject that input. Seems simple, but in the practice it's very hard, because most of the systems that we are working day and night are data-driven systems. You are expected to work with imperfect data, sometimes corrupted data, without your system getting crashed. Very important. What about interfacing? If there's an external system that you are interfacing with, if that system is behaving abnormally, what are you expected to do? Waiting happily and processing whatever junk that is coming in? No. We should disconnect from that system, expect it to come in online with the right state, and then continue. Throw errors, make sure that the operators are aware of the problem, and then get it sorted. So defensive to interfacing with external systems. There are other things that we should be defensive as well, but these are the things that comes into my mind. A list data structure is a very innocent data structure. If you insert 1,000 elements and perform a sort function, let's say it might return in few milliseconds. Later, the same program is being used for a bigger use case, bigger client, to insert 100 million messages. What will happen? What will happen if a sort function is invoked? It will miserably fail. We should always understand that there are implementation limitations. Anyone who has ever written a line of code, a library, without implementation limitations? If you have done that, you should come here and we will all applaud your achievement. It's not possible, because every line of code, every program that we've written, every library that we've written, even the great open source libraries that we see, used by thousands, millions sometimes, written by the big names, they also have implementation limitations. So be aware that there are limitations in every piece of code that you write, every library that you use, every data structure that we use. And it has to be a conscious decision when you are selecting the data structure, the library, the modules, and sometimes APIs. So software developers are humans too. But the God has given us some tools. I call them the static and dynamic analysis. How many of you have used, let's say, SML, Sona, Coverity, LGTM, Valgrind, Cache Grind? Okay, Sona. I thought most of the industry is using Sona. Okay, just few hands. Interesting. So the reason why I said these are God-given is very simple. If you make a mistake, these tools will find it for you before the customer finds it for you. That is the importance of having static and dynamic analysis tools. Maybe it's worthwhile going back and researching a bit about static and dynamic analysis tools. You might be surprised by the number of errors that they can catch. These are software too, so they can't catch everything, and you can't verify the accuracy of a software program by another software program. No. Still, they can catch you very interesting number of issues. And if you can achieve 0 errors, that will come very handy. For us, that was the case. That's why we are paying a big premium for some of these tools, because there is benefits coming out of those tools. Right. Wow. That seems to be a perfect fit for a bride to be. Just like a perfect fit after a verification and validation. So production like C trials, full simulation under load, and UAT testing by a third party are part of verification. So in the world that we are living in, the test systems are small and production systems are huge. They have different data. So it is important that we have C trials. How many of you perform C trials on the software that you develop? C trial is basically using the system in a production-like environment with production data, production users, to simulate it in the production-like use cases. How many of you do that? Okay, probably you can think about starting it. And then fault simulation under load. Something that works perfectly, giving all the green lights at 1,000 messages per second, might crash, might even queue, might cause all sorts of problems when you have, let's say, 100,000 messages per second. That's possible, right? So you wouldn't find that unless you load the system and then simulate a failure. So all the fault simulations are expected to happen along with a load. So these two have helped us a lot in achieving better quality, finding issues that you cannot find in other means. And when we complete all these, give the package to our customers, they will say, yes, you have done your best job. We'll put it in production. No hell. They will say, we don't trust you. We want a third party experts to verify this. Verify whether it is meeting the specifications, the requirements, as well as whether it is fit for our customers. That is the nature of the mission critical systems development, because the clients can't trust anyone. To be honest, they can't trust anyone, right? Because an outage can cause millions of dollars of revenue loss, as well as their neck is on the line. So the third party UAT testing is mandatory. Then comes the real customer. So the real customer is actually connected. Their systems are also connected into the production. And during the production hours, you can't do anything. What we do is, after hours, after the production is completed, we have a dress rehearsal time period. Just like how this lady verifies the fit of the dress, there is a time period where the systems are connected to the production environment and do various levels of testing. It could be functional testing, it could be load related testing. So those are additional things that mission critical systems developers and the rest of the ecosystem is supposed to do to make sure that the verification and validation happens to the level that they expect. It's a lot, but that's the standard. Right. Agile and Lean, they have changed everything that we know of about building software, building cars, building bridges. So mission critical software can't escape from that truth. I see mission critical systems as a symbol, just like Superman. Agile development is like the Batman. Does it fit the analogy that I'm trying to get? Let's see. Mission critical systems, we have these requirements. Agile manifesto says these things. Okay. On this side, we have specifications. On this side, we are talking about working software is more important than specifications. On this side, we have sign-offs and audits and documented quality evidences. On this side, we are talking about customer collaboration. On this side, we are talking about matrices. On this side, we are talking about individuals being more important. Looks like these two can't marry. Is it the case? Can you develop mission critical systems using agile development methods? People thought it is very hard. And over the years, they have tried and tried and failed and tried and tried and failed and tried and somewhat successful. So we, as MilleniumIT, has also went in a similar journey. We've learned something and then would like to share some tricks. So just as in any agile project, small increments and closer involvement are things that you have to get the client's buy-in from. It is very hard, and I think if you ask for the single critical factor that require the success of a program like this, it is the client's buy-in for these two. These are types of clients coming from government backgrounds, auditors and all, regulators and all. So these guys, they used to throw you a specification with hundreds of pages in it, and then expects you to deliver working software after 6 months. That's their working pattern. They know nothing about Agile. They know nothing about being collaborative and working with the software developer to get their job done. They have enough and many work on their plates. So it is very hard for you to get the type of customers to buy in. But there's a lot of art and science in doing that. A lot of senior management involvement, a lot of experimentation, and sometimes you have to have a very tight deadline as well. Without having collaboration, you can't achieve that deadline. So we had a case where we had an extremely tight deadline. Otherwise, we were losing market share on a certain application. So everyone got together. The business owners were willing to cut down features for the first time. Cut down on some of the features to fit into the timeline, willing to talk to the developers to make sure that they understand the business and the functionality, how it is fitting into the application. So we were lucky in that sense, but it is very important that we have the client's buy-in. Right. If you look at the typical development cycle of let's say, mission-critical system, you need a lot of pre-planning, pre-designing, pre-architecting before you start coding, isn't it? If you start writing the code from the sprint one, what will happen? You may miss a lot of areas which you have to think at the design board. But at the same time, Agile talks about a working architecture, a working plan. How do you get the best out of both ways? It is by having a sprint zero, which is permitted by Agile, and which is also called a definition sprint. A definition sprint is therefore upfront design and planning. When you get the basics of the architecture right, that means you can build upon that in the upcoming sprints. So it helps the architects, the planners, everyone, CSMs and SMs and everyone to POs, CPOs, everyone to make sure that they have a concrete, plan and an architectural guidelines coming along for a given release. And breaking down design documentation is very important, because usually mission critical systems come up with the concept of validating a design. For someone to validate the design, you should have a concrete design. But with Agile, you don't have that. So the design comes with a story. If you don't break a big design into a small pieces of designs that will get implemented along with a story, you wouldn't be able to achieve proper agility. That's why it is important for you to break the design into workable chunks as well. So as the design documentation. It takes a bit of time and experimentation, but this has helped us a lot in achieving design verification for a given story. I hope the terminology that I am using, such as the sprints and stories and CI, are also familiar to you. Sorry. Moving on, getting CI to do the hard work. To be honest, this was the most challenging part for us, because we didn't have CI integrated into our development cycle from the beginning. But probably people like WSO2, they must have already had CI built into, integrated into their development cycle. Because of that, it was a challenge, but it was a fruitful challenge. If you don't have regressions running in every sprint, full regressions, by the way, if you don't have static and dynamic analysis tools running in to verify the accuracy of your code every check-in, sometimes every day, you won't be able to ship working software after 2 weeks. That's a real challenge, guys. Shipping bomb-proof software by doing everything that you could do to verify that it is working within 2 weeks. That's the target. So without CI, it's just not going to work. So it's a lengthy, painful journey, but we believe that this is something that we need to get done to achieve the success. So after hard work, these are the areas that I'm focusing on to show you the results of a tier 1 client project. So release duration was like 3 to 4 months. Size of a go live increment was huge, 30, 40 CRs, epics, and cycle time, that is an idea popping up in the business, and then taking it to live, it was like nearly a year. Release go live were very complex, risky, and very stressful. And after going through this transformation, here we are today. We are deploying releases that is coming out of sprints with the third-party UAT partners, that is essentially the client, and then size of the go-live increments is very small. It's just 20, 30 stories, not very bulky. Cycle time, an idea popping up and getting that in production. That is the time to market has reduced dramatically to 3 to 4 months. And then release go-lives are smooth and frequent. So this is one of the experiments, and then getting it evolved to the rest of the programs is the next challenge. Right, with that, I would like to conclude my session. We will have a Q&A afterwards, and we'll see you there. Thank you.